I will be doing problem 4.58. There's four parts to this problem: Part A, Part B, Part C, and D. I'll read the entire problem before we get started. A school system employs teachers at salaries between $18,000 and $40,000. The teachers' union and the school board are negotiating a form for next year's increase in salary schedule. Part A says, if every teacher is given a flat $1,000 flat raise, what will this do to the mean, also known as X bar, and the median, which is written as a capital M. Part B of this problem says, what would a flat raise do to the standard deviation? Standard deviation I'll explain later on, but what will a $1,000 raise do to that? Part C is saying, if instead the teachers receive a 5% raise, the amount of raise will vary from $900 to $2,000. Depending on the present salary. What will this do to the mean, also known as X bar, and the median, capital M? Part D of this problem is saying a flat raise will not increase the spread of the salary distribution. What about a 5% raise? So what will a 5% raise do to the distribution? Specifically, will the 5% raise increase the distance of the quartiles from the median? Will it increase the standard deviation? So for part A, to begin, I'm going to give you the definition of what a mean is. A mean, also known as X bar, is the average number in a set of data. So for an example, if you had a set of data that is 10, 1, 3, 15, and 8, you'd add these numbers together. You'd add these numbers together, like so, and this equals 37. Then you'd count up how many numbers you have, 1, 2, 3, 4, 5, and you divide this number by 5. So the average would end up being 7.4. The median of a set of data, also known as capital M, is the center number in a set of data. So if I have the same set of data, you want to put it in order, so it'd be 1, 3, 8, 10, 15. So the median of this set of data would be 8 because it's the center. Another part of this problem is asking about the extreme quartiles. Extreme quartiles are on, say you have sets of data on a line. They are the highest and the lowest numbers on the data. So in this data set, it would be 18,000 and 40,000. Those are the extreme quartiles. So in this problem is asking, what would happen to the mean, the median, and the extreme quartiles if everything was increased by $1,000? Well, you put your extreme quartiles on there, and let's say our mean and our median are right here in the middle. If everything was increased by $1,000, show a little diagram here. Everything in that set of data would move up by $1,000, and that is how it would affect everything in that data. So for part B of this problem, it is asking what would happen to the standard deviation. Let me write this out. So I'll give you a definition of what standard deviation is. It is the measure of a distance, of the observations. So what that means is, so say you have a line again, and you have a point here, and you have a point here. It's the distance, it's the measure of the distance between these two numbers. So in this question is asking, if you have a $1,000 raise again, $1,000, what will it do to the distance between the quartiles? Well, if everything is moved up by $1,000, like I did in the last problem, everything moved up $1,000, well then, wouldn't it be the same distance between? So it'd be the same distance here as it was here. It's just that everything just moved up $1,000. So a flat raise of $1,000 would not change the standard deviation. In part C of this problem, it is asking what would happen if there was a 5% raise. And the amount of money people will earn will vary between $900 and $2,000. So it is asking what this will do to the mean and to the median. I already told you what those two things are. So what will this do? And so let's plot it back out. Let's say here's our extreme quartiles. We have our mean and our median. Let's just put random points on the data thing. Each will increase by 5%. Everything will increase by 5%. No matter, some greater than other, depending on how much you're making, but everything is going to. So no matter what the numbers are on the thing, everything's going to increase by 5%. So everything's just going to move up. That is how it affects the mean and the median. For part D of this problem, this is where it gets interesting, because the part D says a flat raise would not increase the spread of the salary distribution. What about a 5% raise? Specifically, will a 5% raise increase the distance of the quartiles from the median? From the median, quartiles. Will it increase this distance or this distance? Will it increase the standard deviation? Oh, I can't write. Okay, there we go. The answer is yes, it will, because the lowest quartile, so the one down here, 18,000, it'll move up a little bit because 5% of 18,000 is probably about $900. The median will probably move up a lot more than that, will, because it's a bigger number than 18. And 40,000 that's over here will move up a lot because 5% of 40,000 is a lot more. So it probably would be $2,000. So in this section, the mean will move away from the lowest quartile, and the highest quartile will move away from the mean. How this affects the whole standard deviation is, so if you have an original line, so if you have your original numbers, so 18K is the lowest amount. Oh, put the K over here. And you have 40,000. And you have the median. This will only increase by a little amount. This will increase by more because it's a bigger number. And this will increase by the most. It's going to go off the page. So what I was saying is that these new measurements are going to be bigger distances apart from each other. So it'll increase the standard deviation. So, in review, for part A, when you have an increase by whatever amount, the mean and the median and the extreme quartiles will all move up together. All move. For part B, the standard deviation of a flat raise will not change. For part C, when you have a 5% raise, the mean and the median will just move up 5%. Move up 5%. But in part D, a 5% raise will change the standard deviation because the spread will increase. Thank you for listening.